journal from, which I realized I didn't even tell you what the questions were. Okay, so everybody put their pencils down. Stop eating your floats, ice cream. I need all eyes up here. All right, so we have these 3 questions, and if you can't read them, you're more than welcome to sit on a clipboard, or I can come read them to you.
Hey, what he said Miss McLean made a mess in the trash can or something.
Right outside the door.
All right, so the first question, it says, explain the states of matter changes. So what are the 3 states of matter? David?
Solid, liquid, and gas.
Perfect. So when I ask this question, you can use the ice cream as an example. You can talk about water and how it goes to cubes, to ice cubes, and then to evaporation itself. Any example you want, as long as you're explaining what those 3 processes are and how it goes from one to the other to the other. Does that make sense for that one? Okay. Question number 2, it says, what type of change occurred and why? So when we did this experiment, Ms. McLean talked about how both physical and chemical changes occurred. So maybe talk about both of them and where you saw those changes happen and why they happened. You can't just be like, this experiment where I made ice cream was physical and chemical changes. That doesn't give me a lot. I need to know why you want to say that. Riley brought up a really great point. When you mixed the soda with the ice cream, it created a change itself. Riley, what change did it create?
It created a chemical change.
Why did it create a chemical change?
Because when you mix the ice cream and the soda together, you can't get it back. You can't separate it. Because
Exactly.
it kind of melts together.
And so if you didn't do the ice cream float, but you added sprinkles and chocolate chip, would that be a physical or would it be a chemical change?
Physical. Physical.
Physical. I heard Noah and Peyton say physical. Noah, will you tell me why it's physical?
Because you can remove the sprinkles or the chocolate chips out of your ice cream or float.
Do y'all agree with him?
Yeah.
Okay, I agree with him too. So again, I want you to tell me what changes occurred throughout this whole process that we went through. And the last question is kind of like a little fun question. There's no right or wrong answer. I just want to see what you come up with. So it says using the vocabulary. We talked about 4 key vocabulary terms today. Can someone tell me 2? David?
Physical and chemical.
Physical and chemical. And then what are 2 more, Delaney?
Irreversible and reversible.
Beautiful. So I want you to use these vocabularies, especially in this 3rd question, because I want to see if you really truly understand the concept, which most of y'all do, and I'll be able to see that through your explanation. But the question is, what would happen if you used pepper, so you guys know like black pepper, instead of ice cream salt? Would you get the same reaction? Would you get a different reaction? So tell me what you think. Maybe even tell me what the new solution would be if you use pepper. Would it stay the same? Would it become pepper ice cream? Or I don't know. That's up for you to tell me. All right, does that make sense, everybody? Yeah, so it's whatever you want. It's kind of your own hypothesis of instead of the ice cream salt, we'll use pepper. Does that sound cool, everybody? All right, does anybody have any more questions before y'all dive in and finish? James?
I'm confused on number 3.
Number 3. Will you read it to you?
It's what do you think you have to do to freeze an object? And then it has like a blank.
So in this experiment, what did we do to make that solid with all of our ingredients into the ice cream? Braxton?
We had to like change the temperature and like put ice around the ice cream.
Yes. What action did we do? Yeah, shake it. We shook the bag. So that would be an explanation or a reason of how it went from the solid to the frozen object itself.
I just put